Welcome to section 7.3. This is entitled Rational Expressions, Adding and Subtracting. How do you add and subtract expressions, fractions with variables in them? Well, it ends up being that this section has historically been a difficult one for a lot of students. So what I'm going to do in these videos is not try to take this entire chapter in one big video. I might actually go 3 or maybe 4. I haven't decided yet. Separate videos on this section, and this homework really should have been separated. Instead of having 25 problems in this one homework, this homework really should have been separated into separate chapters, sub-chapters. But I'm going to take the approach of maybe doing the first 6 or 7 problems and stop the video, because it's probably best to deal with this section in pieces. So let's take a look. What am I talking about when we're talking about rational expressions, adding or subtracting? Well, remember, what's true with numbers is going to ultimately be true with expressions with variables in them. Like here's an x there. It doesn't really change the way you do anything. If I give you, say, 2/5, and I want to add, let's say, 7/5. 7/5. Okay. What's the answer to this problem? Well, this problem isn't actually all that bad. This problem's not all that bad, because what I'm going to do is notice that the denominators are the same. And if the denominators are the same, all you got to do is just add the tops. That's it. This is 2 plus 7, 9/5. Okay? And then you take your fraction that you get and see if you could simplify it. Well, 9/5 you really can't do much with. It is what it is. So let's try another one. Let's say we have 1/5 plus 7. Let's try another, not 7. Let's not do 7. I want to do another one. Edit, undo this. Edit, undo. Okay. Let's say I want to do 9/5. That's a good one. Okay. Again, when the denominators are the same, not a problem. You just add the tops. That's all you do. 1 plus 9 is 10 on the top. And the answer will have that same common denominator that we were so happy to see. And then the fraction that you get, that's nice, it works, but certainly 10/5 can be simplified to be 2. And that's the answer you would put in the computer. So let's take a look at this problem over here. Okay, I see, let me separate this. I see this as 11x over 39 plus 2x over 39. Well, I'm extremely happy because the denominators are the same. That's a 9. That's a 9. And if the denominators are the same, the end answer is going to have the same denominator. And then all you got to do is just add the tops. Okay? It's the same addition that you would do in Algebra 1 with like terms. I see 11x plus 2x is 13x. Okay? Now, don't enter that, because that's not going to be correct, because you could simplify this. You'll always have to simplify fractions. That's the issue with fractions. They always have to be simplified. So 13 over 39, you know what? I think 13 goes into 39 evenly. Yes, it does. So 13 goes into itself once. 13 goes into 39 3 times. So the end answer is going to be 1 times x, which is a plain x, over 3. And there's the answer for that problem. X over 3. X over 3. Let's check it. Good job. Great job. Okay, so let's try the next one. Now, subtraction's the same deal with the same. It's instead of adding your tops, you would be subtracting the tops. But there is one little gotcha with subtraction that I have to show you. So let's go ahead and file new and do a new canvas. And it looks to me like I got 2a over 9y. I don't care that there's two separate variables. That's all right. 6a over 9y. All right. I'm happy because I see the same denominator. And when you have the same denominator, your end answer is going to have the same denominator. Okay. Now you just subtract the tops. Subtract the tops. Now, when subtracting the tops, there's a little gotcha with subtraction. That gotcha doesn't present itself here because there's only one term, okay, to the right. But this is 2a minus 6a, which looks like it's minus 4a. And you know what? I think that's the answer. I don't think there's not much you can do with 4 and 9. A's and y's don't cancel. So I'm going to put that into the computer and be happy to see a beautiful green box. Over 9y. Check that answer. Great job. 2 out of 25. Boy. Oh, okay. I think I can sneak this right over here. Separate this. Separate this right over here. So we got x over x minus 3. Now remember, I don't want to put the parentheses here just yet, but just remember that this is a bundle, because that's what pluses and minuses do. They bundle. They bundle expressions together. Here's a bundle up here. 3x plus 5. Okay, I don't really want to show it right now because I don't really need to bundle those things at this point. Because here's the thing. I've got the same denominator, x minus 3. The end answer is going to have an x minus 3. Okay, the end answer is going to have the same denominator. The top is simply going to be the tops, the numerators added. So x plus 3x plus 5. Okay, this is what I'm going to do. Combine your like terms. 4x. That canceled. That combines the x terms plus 5. And I'm thinking that's the best you can do with this. Okay. Here's the problem. This is a bundle here. And that's the bundle. I don't even think about canceling the x's. I'll be very disappointed if you do. Because you have implicit bundles here, and you can't go inside the bundles. The only way you can cancel anything is through factors. You have to factor things, and I can't factor the top, so there's not much you can do. I would say that's the answer for this problem here. 4x plus 5 on the top, x minus 3 on the bottom. Check your answer. Fantastic. See, these problems, you're going to say, well, what's so hard about these problems? How bad can these problems be? Because the issue is the denominators are the same. The first 6 or 7 problems in this homework set, the denominators are the same. And so, yeah, if the denominators are the same, it's straightforward. It's not a problem. But if the denominators aren't the same, then you get an issue. Okay, and I'll save that for the next video. That's what you do with the denominators not being the same. So let's come over here. Close that. Close this. Let's do a new file here. Oh my God, I got bundles everywhere. I got 8x plus 2. That's a bundle, but I'm not going to show that as a bundle just yet. Let's make a prettier 8. And this is 2x minus 5. That in itself is a bundle. That's good. Minus that same bundle. 2x minus 5 on the bottom. And this is 6x plus 7. Now, I'm sort of happy because the denominators aren't the same. Are the same. They are the same, obviously. They are the same. The end answer, which I'm going to put right below, is going to have a 2x minus 5 in the answer. And then what you're going to do is subtract the tops. Now, here's the issue with subtraction, however. Okay? When you got multiple terms on the right, you have to subtract everything to the right. In other words, this is minus 6x. Minus 7. People forget that. This is a bundle over here. That's a bundle. A minus in front of the bundle changes the sign of everything inside. If this were a plus, yeah, no problem. Just combine the x's and add the numbers and you're good to go. With subtraction, however, the left side of the subtraction is okay. Leave it alone. But I got to do minus 6x minus 7. People forget. A lot of people say plus 7. They literally take this and they say 8x minus 6x. Okay, that's good. 2 plus 7. It's wrong. It's 2 minus 7. You have to subtract everything on that side. And so once you do that, you're good to go. Yeah, let's see. Top thing is got to combine your like terms. We got 2x for this term and that terms. 8 minus 6. 2 minus 7 is minus 5 over 2x minus 5. Well, guess what? That's a bundle. And that's a bundle. And don't you see something that's exciting? We have the same bundle top and bottom. See, don't enter 2x minus 5 divided by 2x minus 5. It'll be miserably wrong. Okay? You have to factor. You don't have to factor. In this case, you don't have to factor, but the factors are the same. So good, cancel them out. And when everything cancels, you're left with 1. There you go. Who would have thought that big mess that we see there is the number 1? Great. Good job. Okay, 5 and 6. Don't save this. File, new. Okay. Let's say, all right. I'm happy. The denominators are the same. That's good. So I'm going to take 11 plus 3m up top divided by 5m minus 2 plus 17m plus 3 over 5m minus 2. Okay, not a problem. I see a plus. Okay, we're going to add the tops. You don't have to worry about changing signs. I see the same denominator, so my denominator on the bottom is going to be 5m minus 2. And so when I add this together, what do I get? I get 11. I got 3m plus, see, I'm adding up my m terms. They're like terms. 3m plus 17m is 20m. What do we got here? Negative 11 plus 3. That's going to be negative 8. Now, you might say, well, geez, let's enter that. Okay, I'm going to enter that. I'm going to show you that you're going to have a problem. Okay, 20m, because people forget students typically forget the stuff that they learned in the previous section. You have to apply that stuff. Oh, I'm so excited I did the right work. Oh, wrong. That's not right. Okay, see, this is a bundle. And that's a bundle. Certainly you can't cancel anything right now. But if I were to factor the top, let's see, 20 and 8, I can pull out a 4. When I pull out a 4, I divide everything by 4. 5m minus 2. And the bottom has got a 5m minus 2. Oh, hey, there's the excitement right there. That bundle and that bundle cancels, leaves you with 4 over 1, which is obviously the number 4 is a lot simpler than what I typed in. Okay, check your answer. Nice work. So don't forget, once you do this, you have to simplify the fraction using the stuff that you did, I think, in section 7.1. Section 7.1. Oh my God, look at this. Not a big deal. Not a big deal. Don't save this. File, new. Okay, now, when you do this problem here, you might be tempted to try to factor this. Don't do extra work when you don't need to. Okay, I'm very happy that the denominators are exactly the same, and that's a good thing. Okay, so what I'm going to do is say x squared minus 5. And so what I'm going to do is right now, I'm just going to say blah, blah, blah. That's okay. I really don't care what the denominator is. I do know that the denominator is going to be exactly the same. And if the denominators are exactly the same, I don't need to factor anything right now. Okay, so right now, I'm more concerned about the top. X squared minus x plus 6 over the same blah, blah, blah. Okay? Now, be careful when you do this operation, when you do a subtraction. Okay? What's going to happen is the left side, see, I'm taking a look at the tops. The left side of the subtraction doesn't change. It's whatever is on the left side. But we got to remember that you're subtracting everything inside to the right, everything. If you've got 3 terms, you've got to subtract 3 different terms. So that becomes negative x squared. That's a 5, by the way. Plus x. See, minus and minus is plus. It changes the sign of everything on the right. Minus 6 over the blah, blah, blah. And that blah, 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 again, is that same common denominator. And the last thing that you end up doing is combining like terms. Let's see, the squares, x, I do my squares first. X squared minus x squared is 0. 0 x squared, they cancel out. X is another, I go in the order of the exponent. X is by itself. And then we got minus 5 minus 6 is minus 11. Now, of course, when you enter this into the computer, you're going to enter, not going to say blah, blah, blah. You're going to say x squared minus 6x minus 4. Now, before I do enter it into the computer, it is possible at this point to say, well, geez, can this thing that I know is correct, I know this is correct, can it be simplified? There's a chance that if I were to break this up into separate factors, that maybe you can generate a factor that cancels out the top, but you can't. There's not much you can do with this. Okay, in fact, you can't even factor this because there's no 2 numbers that multiply out to be 4, add or subtract to be 6. It doesn't even exist. So that it is what it is right here. So let's just put that answer in there and say x minus 11 divided by x squared minus 6x minus 4. Check your answer. There you go. Now, I'm going to stop the video here. So after this video, you should be able to do the first 6 problems. Now what happens is they're talking about this thing called LCD. That stands for lowest common denominator. And there's a whole process that I need to show you about lowest common denominator. So I'll stop the video here and do the first 6 problems in that homework. Okay, see you next.